Yeah. Okay. So I was talking about. Let me just complete it first, and I'll reach out to you for questions. I think everyone can hear me. Can anyone quickly confirm me if they can hear me?
Yeah, we can hear
Yes,
you.
yes, we can hear you.
Okay. Okay. Cool. Okay. So I was talking this now since we are having a replication concept of replication in force. Now what will happen is I will have to need three times the space of actual data to store. Okay. So storage is cheap, so that won't be a problem. Even if I would have to need, some more servers to increase this space to make it three times, that is not going to be a expensive affair. But yes, this RAM is definitely going to be an expensive thing because RAM is still not cheap. It's still expensive. So this is where the distributed computing gives you another liberty that you can use commodity hardware. Okay, so commodity hardware is basically a cheap hardware which is unreliable. Unreliable in the sense it can go down, and mostly it's because it's unreliable because its RAM is still going to be less. Okay, so you can use some commodity hardware wherein it's going not going to be that expensive, and you can have multiple such hardwares connected over in a cluster. And distributed computing is devised in a way that it can tolerate a few downtimes, few servers going down. So distributed computing can handle downtime of some of these servers. Okay, so now you can have multiple servers connected. You can have three times the space, and you can also ensure that since you're not using much, you are not using that expensive things, uh, expensive software servers or physical hardwares. You can have this liberty of storing as much amount of data that you. Okay, so these kind of things were not suitable in earlier environment of RDBMS. What options that we had when we were using RDBMS, so let's say this data grew. So what I could have done was I could have replaced. So let's say this data was being stored on the single physical server, which is having 200 terabytes. What else could I have done was I could have increased the disk of the same server. Either I could have attached, let's say, 5 or 7 more disks. But yes, every server has a limited number of slots. Even in your laptops also, or in your PC or laptop, you can attach only. It only have certain slots. Wherein you can attach the hard disk or some external hard disk or hard drive. Similar is the case with a physical server also. It can tolerate, it can be attached to only a few limited number of extra hard disks. It can be, so what I know is that it's around 8 or 16 slots which are available in each server. So each server can be attached to 8 or 16 kind of different hard disks, but that is still limited. You cannot, expand after a certain amount. And definitely if you move on to larger or a better physical servers, so there is something known as supercomputers also. Supercomputers can have, I think thousands of RAM, 1000 GB RAM. I'm not sure completely about it, but yes, it's definitely can have better processing, and you can attach and can be attached to more disks. But yes, definitely it's going to be much expensive than the solution that we are searching for. So this is not going to be a better approach. Definitely, it's better to use a distributed computing environment, because now you have all these liberties. You can use commodity hardware, which is cheap. It's not going to cost a lot of burden onto the companies and organization. Mostly, the companies that I know, they are not using even they're using similar physical servers only. So these are like general purpose physical server available in the market, and companies have been using these only. But yes, if you or if I want to create a cluster for, let's say, my testing situation, I can create it as a commodity hardware. I can pick up five six laptops, which is not that expensive, and I can make a cluster out of it. But yes, companies and organizations are still not comfortable with this. They are using general purpose servers, but even that is also better. Okay, so this is where distributed computing plays the role in handling larger data sets, in reducing cost, in reducing the latencies while fetching and storing the data, and it introduces new concepts such as replication, rack awareness, and there are a few more concepts which we'll talk about as we move forward further. It has introduced this concept of master slave architecture, and it also has this uh, concepts of data locality, which we'll talk of sooner. There is another concept known as data locality, which basically means data will be processed on the same location where data sits. Okay, but we'll talk about it when we talk about the processing concept in distributed environment. So definitely it's better approach to use distributed computing when you are dealing with data which is larger in size, and which can cause problems with the normal SQL instances. Okay, and Hadoop has come out to be one such product, I would say, of distributed computing. So Hadoop is based on, we can say it, Hadoop database is based on the concept of distributed computing in master slave architecture. Okay, so it's also a master slave kind of architecture when we are dealing with Hadoop database. So there's going to be one server which is acting as master, while other will act as slaves of that server. And yes, since it's a based on distributed computing, all these things will come into force. So data is replicated in Hadoop. You have cluster of servers. You have concept of rack awareness and topology, where the Hadoop database will know which data will reside on where. And you can use commodity hardware if you want. You can use cheaper hardware. And then there is concept of data locality, which is basically based on the processing capabilities. Okay, so this was, I think, a little summary of why. So what is Hadoop? What is distributed computing? Why we need it? What was the need for it? Okay, and how does it is better, and it helps in reducing the issues that people were facing with earlier RDBMS kind of systems. Any questions so far before we move on to, I'll give you an overview of cloud and Linux also. And I'll also try to cover up creating a virtual machine on the AWS. Any questions so far from anyone related to this? I'll be happy to explain it again if you're not if anyone is facing issues. So so far it's little theoretical, but yes, it is required initially, and as and when the time proceeds, we'll be getting into more practical stuff also. But yes, these concepts are important, and that's why I also told everyone to go through them at least once. Okay, Imtiaz says so far okay. Isabra, are you still having some trouble with GoTo, or is it fine now?
Yeah, it's okay. I'm okay with it. I was just, I think it's my laptop problem because when I was, now I'm in phone and also in my laptop. I'm looking at my laptop to
Mm-hmm.
see your presentation, but while I'm talking to through my phone,
Mm-hmm.
I think anyhow I have an issue with my laptop, but I really don't want to deal that right now.
Okay, okay, okay. Sounds good.
Yeah, I have a little question with that cluster.
Yeah.
That so
Mm-hmm.
cluster is like a group of computers, like a master slave group of servers. So
Yes.
here, when you were presenting that the client one
Mm-hmm.
has like 6 servers, including the master and 5 slaves, right?
Mm-hmm.
So, so is this client is the cluster? So
This client you're talking about?
yes, this client.
No, no. So client is not part of the cluster. Client is basically an external
Okay,
entity. Okay, so if I just
okay,
segregate it out, client is an external entity who wants to contact my server for anything.
right, okay. So these all server like from S1 to S6 all together it's a cluster.
Yes, S6, and
Okay,
you also have this capability of adding more to this. These will all,
in one cluster.
yes, in one cluster. So this box in here is basically a cluster, while everything out of it is a client to this cluster. And you have this capability of adding more and more servers to this cluster also. You can grow it. That's basically horizontal scaling, what we call.
Okay.
Cluster and Hive. Okay,
So
so
and
Barua, we haven't reached Hive yet, but yes, Hive is one such service. Hive. So as we were talking of this SQL kind of queries, right? This queries. So if you
mhm,
want to run similar queries on a big data environment like this, you have this service which is provided by Hadoop, which is called Hive. So Hive is a service, or it's a, you can say it's an application that you use to query over the data that you have stored in the cluster. If I give you an example for, let's say, my laptop itself, okay? So in my
mhm,
laptop, I have all of these data stored somewhere, right? I have all these data stored away somewhere. But if I want to access, let's say, if I want to access this Word document, this is a data,
mhm,
has a space associated with
right,
it, right? It's 112 kilobytes. Now, if I want to
mhm,
access this data, I will have to have an application, which basically here is Microsoft Word. So this
mhm,
data can only be opened in Microsoft Word kind of application. So similarly,
mhm,
In a cluster, you have data stored in these servers, and then you have applications
Mm-hmm.
through which you can access those data. And Hive is one such application. So far, I would summarize it like this. As we move ahead, we'll have a separate session. We'll explain all the intricacies of this application Hive also. Similarly, it provides various other kind of applications. So Hadoop is basically an environment of multiple applications like this. So
Okay.
for storing data, you have HDFS. For processing that data, you have Yarn. You also have
Mm-hmm.
Hive, through which you can give basically a structure. Since, as I told you, if you want to run a queries in similar format, how you were running in SQL, like this select, like this creating table, Hive give you that capability wherein you can provide a structure to even the unstructured data sets, and then you can run queries over them. Similarly, you have something called HBase, Spark. So all of this is basically, they are all types of processing while data is being stored in HDFS. So as and when we move ahead, you will talk about this also. Okay,
Okay.
somebody was
Thank you.
saying about master slave. Please explain master slave. Okay, see, okay, master slave. If I give you an example, right now I have 12. I have around 14 people joined in this meeting. Okay, I can see 12 people are joined in my meeting. Now I'm sharing this screen and everybody is seeing that, right? All of you 12 people are able to listen to my voice also. So who is the master here? I and my system is considered as a master. I'm like, don't go literally into the names. So basically, these are just names, how servers are architectured, are given terms in terms of this architecture of cluster. So we all 12 people in here are basically a cluster right now. Okay, all of us are in a cluster. Your computers through which you are connected are basically acting as a slave to my laptop. Whatever my laptop is delivering, whatever content my laptop is delivering, all of your computers are able to fetch that, and you you are actually the client of your computer. Similarly, I am also a client of my computer. Okay, so cluster is basically connection, and all of our environment, all of our computers are connected to this application GoToMeeting, which is actually making a common network for all of us. Okay, so this is a platform which is giving us a common network. Similar is the Zoom. So it gives you a common networking platform through which you all get connected. Similar is the case with a cluster also. So cluster basically is group of servers. One will act as a master, similar to my laptop right now. My laptop is acting as a master. It is delivering, it is telling you what you want to see. So if I scroll down, scroll up, whatever application I'm going to show you, you are able to see it because master is doing that. Similarly, when it comes to cluster, one of these servers will act as a master. It can be anyone. Okay, so the architect who is making this cluster, who's architecting this environment, will decide upon which of these server will act as a master, and whatever external thing wants to connect to this cluster as a whole, it will contact the master, and then master will say, okay, I have around this many servers. Your data that you are requesting is basically stored on this server. So master will have a separate information about the cluster as a whole also. Okay, I hope this makes you understand. Okay, so think it of as a way wherein you have multiple computers and they are all connected to each other through a network, common network. and they can interact with each other, they can talk to each other, and then one of them is acting as a master who is taking who is like a, so when you are in a club, like imagine yourself in a schooling environment. So teacher used to make a class monitor, or a class prefect. So that's basically, he's acting as a master to the whole class. He's guiding the whole class what to do. He's maintaining the record of who is available in the class, who is not, so which server is down, which is not. That is all being managed by that single server, who he's just having the responsibility of managing the complete environment, and that's why it's called as a master. Okay, so this is a master slave architecture, and Hadoop is going to be based on this. So there's going to be some services which will be associated with the master components, and there will be separate services which will be associated with the slave components. And we'll talk about them as and when we proceed forward. Okay, a quick introduction to cloud now. If you have any more questions, you can think of any question. I would love to hear some creative questions also. So why are we not using this? Why are we not using that? If you can think of such kind of questions, that can also be very good. Okay, let's move on to cloud. And I will just be giving a little introduction so that you guys can be familiar with what is happening, when we use cloud. Okay, so yeah. Now there is another thing. So far, the market only had physical servers available for us to buy them, maintain them, store them. Okay. So, for example, let's say I go to the market, I buy a new laptop. So once I buy it, this is my responsibility to maintain it. Even if I want to use it every day, I'll have to connect a charger, and I want to, let's say, want to protect it. So if it's a Windows machine, I want to protect it, I will have to buy a McAfee, like virus protection also. So all of this comes into the maintenance part. Then I need some secure place where I can store, whenever I can keep my laptop once I'm not using it, or even if when I'm using it, I would need to place it in some location, right? So all of this were the issues, I would say, with physical servers also. So companies which had around thousands of servers, let's say, they need to buy a data, a location where they can place those servers. So they were basically called as a data warehouse or data center. Okay. So companies used to store their thousands of servers in data centers. They are still doing that. Larger companies, as and when the data grow, and when your more servers are added, you might have to create multiple data centers across different locations also, right? So, and since they are physical servers, you'll have to keep on maintaining them. So you'll have to make sure that they are in working fine condition. Okay. So it's not just about buying them. The problem now is about maintaining, storing, and a lot of things that come in between. Okay, so this was the trend so far. Now they have introduced something known as cloud. And the major players. So first of all, cloud is a virtual machine environment which uses shared, it can be shared, it can be dedicated also, but mostly it's shared, which uses shared hardware to deliver. One second, guys. Okay, so cloud is basically it provides you a virtual machine environment which is basically using a shared hardware at the back end, shared hardware whose information is not available to us, is not shown to us basically. You can demand that if you want, but yes, ultimately it's not shown. And we don't have to maintain, store such machine. So basically it's not a physical server, it's a virtual machine, it's a virtual environment. And why is it called cloud? Why this name cloud? Because all this information, all this is all the hardware which is being used at the back end, they are shared. Okay, so the major player in the market right now is Amazon. Then you have Google. Then you have few more people in the market: IBM, Orange, uh, Oracle is also coming into Oracle Cloud. Okay, so Amazon has this product called AWS, or Amazon Web Services. Right now, it's the largest player. Then you have Google, which is called Google, which is a cloud platform, GCP. It's basically short form for GCP. IBM also has its own cloud. Orange also has its own private cloud, and Oracle also has its own cloud. Okay, so cloud. When I say cloud, so Amazon AWS, it has multiple data centers all around the world. It has physical servers available, but if I want to create a server on AWS, it's going to be a virtual machine and it will be using one of the backend physical servers. And I don't have to maintain, it's not my responsibility to maintain those servers which are provided by Amazon. So Amazon will do that for me. I just have to create the machine. I can even, increase it, decrease its size whenever I need. And I can, so it's more liberous for me to work with a cloud environment, and I don't have to commit for maintenance and storing of such machines. So this is how cloud is beneficial. Okay, so let me give you a little. Okay, once you download this Mobex term, and I am repeating once again how you launch an instance. Okay, for summary. So once you create an account on AWS and you search for EC2 virtual servers in the cloud, you click on it, you will land on this page. Okay, we will land on this page. Then you will see no instance will be running for you. You click on instances. On the top right, you see launch instances. Click on it. In here, you will search CentOS. You will click on the marketplace. You will select this free tier eligible CentOS 7. Select it. On the instance type, you will just continue for now. You will let it be as it is. You don't have to change it because I want to use the free tier eligible, which is T2 Micro, which provides me 1 GB memory and 1 CPU. Let it as it is. Click on next. Let this page also as it is. Click on add storage. Let this be also 8 GB only as it is. Add tag. You can add a tag of name if you want. Security group. This is important. You have to create a new security group. You can rename it from here. Give it any name. Instead of SSH, make it all traffic. Instead of custom, make it my IP. My IP basically means my own IP address. Once you're done with this, click on review and launch. Just check it's appearing free eligible and hourly software fees is only $0 or no fees. When you click on launch, it will ask you. So in here, you'll have to create a new key pair, give it a name, download it, and once you download it, then only this launch instance option will be enabled. You just have to click on it and the instance will be launched. Okay. Right now, I'll just cancel all of it because I already have an instance created. And now I want to connect. So once you have this downloaded this Mobex term, or even you can use your own command prompt, but this is a little better option for those who are using Windows. So I'll copy this public IP address. This is the one I'll be using to connect. Okay. Let me start the local terminal. Okay, to connect to my server, I will use the command SSH. Then I'll place CentOS at the rate the public IP address. This is the public IP address that I copied from the AWS. I will have to provide the PEM also, this key, the key that I downloaded, this key. So let me go into that folder and make this key available to Mobex term. Mobex term folder will be found in documents, Mobex term, home. I'll just place that key, copy that key over here. Okay, so SSH -i b9.pem is my key name. Then CentOS is basically the username of this server that I'm going to connect to. And once you have written this command, press enter. And now I am connected to my server. I want to check my RAM. I can run this command free -h. So you can see around 989 MB of RAM or 1 GB. Since I choose 1 GB, some of it is being used by the process itself. This is my free RAM. And if I want to check my disk, this is RAM. This is how, if I want to check disk, it's df-ah. So I have 8 GB of disk space. So this is basically a virtual server created in the AWS, and this was this IP address through which I connected from my local laptop. Okay, so I'll stop the class at this point for today, guys, and I want everyone to at least create an account on AWS before you join next class. And also you can follow this video that I'm going to share to create an instance and connect to it. So for those who doesn't have VirtualBox, installed, they can also do it using AWS. And I would prefer everyone to use AWS instead of VirtualBox, because VirtualBox will ultimately slow down your laptop. Okay, it's not a better approach, but yes, it's all totally free. But I've also given you a way of creating a free server on AWS only. Okay, so if you want to practice out Linux, and if you want to practice out how to create an instance on Amazon, try this step out. Okay, so we'll close today's session on this note. Any questions, guys?
Yes, I do have a question.
Yeah.
So I did do the VirtualBox, do the installation of the CentOS in the VirtualBox. So if it's going to slow down my computer, if we're not going to be using it, if I'm going to do the AWS, should I just delete it, like uninstall it from my laptop?
So if you have installed it, it's fine. You can practice since you have already done the steps. You don't no need to uninstall for now. You can practice whatever Linux command that we are going to practice in the next week on that also. But
Okay.
yeah, that is fine. But yes, you ultimately will have to come to AWS for all our future classes. So you can test this also out on AWS. Okay. And once
Okay,
you
thank you.
do it, you will disable, like delete it in future. Okay. Any other
Okay. Thank you.
questions? Any other questions? Yeah, thank you. Okay, so I've just my focus for today was to give you an overview of what all services, what is distributed computing basically, what is cloud. I'm left with Linux, which basically I need more time with, because this is a new operating system for, I think, a lot of you. I'm not sure if you have already have Linux on your laptops, but yes, we'll be discussing it in more detail. We'll practice out more stuff. I'm going to share this text, whatever we have, notes that we made on the same drive. I hope everyone will have access to that now. If you don't have access to it, you can click on the same link and it will forward a request to me. Okay, just okay. I'll upload this text to the drive, and also this video that I'm recording right now. So this video will also be uploaded. It will take some time, so probably tomorrow morning when you wake up, you might see this video already uploaded in the drive. Okay, so I'll leave it with this for this week, guys. If any questions you still have, you can post it on the WhatsApp group. I'll be happy to help you, and try to, you know, uh, read out the text, whatever we created, the notes that we created today. Email, I think, Barua, the video is going to be a little larger in size. It's going to be it cannot be emailed. That's why we have been putting it on a drive folder. But text I can email if you want. This notes I can email to you. That is fine. But this is still, we have concepts for Linux to left out. So we'll continue with that on probably in the next class. So far, the homework for all of you is to practice out some Linux. So if I give you some links from where you can practice, So once you have created this, server either on VirtualBox or either on the cloud, and you're connected to it, just try some Linux commands, practice them. You can use any of these websites. For example, if I open this one, and don't worry about it, we'll be discussing everything in detail. But yes, since you have time for a week before we meet on Thursday, so let's start from PWD, for example. You can come back to the server again and type PWD. PWD stands for present working directory. So it gives you some answer. So this basically means the current directory that we are in. Then you can go ahead with the next command. Who am I? So who am I means who user, which is the user. So right now the user is CentOS, so it returns CentOS. Then you have this command clear. Clear will clear out every content, whatever you can see right now. It will clear that out. Don't run exit for now because that will exit it. Then you have date, cal. So this is very less. I think PWD ls will list out all the files. Just try to practice such commands on your own server also before you come in the next class, because then it's going to be a little easy for me also to take you through all these commands. So command is basically, Linux, everything is on this black screen, Linux operating system. So whatever we have to do, whatever we have to do was when we had this like good looking icons, you just click on them and open whatever. Let's say if I want to open this file, I could just click using my mouse pointer, right? But that's not the case with Linux. Although it has a way you can create such UI also in Linux, but mostly on Linux, all the things is done using commands. Okay, so you have ls to list the files. If you want to open a file, you have to use cat to print out the content of the file. If you want to edit a file, you have to use vi. This way you can edit this file. So mostly things are done using commands when you are on a Linux environment. So it's good. It's very important to understand these commands. Okay, I think we'll end this session. It's a little late now also. I won't take much of your Sunday night. But yes, practice out the stuff that we have done today, okay? And keep on learning. As I told you, start spending some time every day. Make it a habit, as a disciplinary habit, to spend some time learning these concepts. And any questions, are always there on the group for you. Any other questions before we leave? Okay, thank you for connecting, guys. Good night. Let's meet on Thursday. Good night. Goodbye.